Okay, we'll start. Thanks for coming to the lecture. Right, today we're going to be revisiting our OOP concepts. And a lot of the time, you've been looking at, well, for the last couple of years, I guess, you've been looking at Java, which is an object-oriented programming language. You may have used OOP when using some other language as well, like JavaScript has a nice OOP way of developing. In fact, JavaScript from a design perspective is a bit of a nightmare because you can have functional programming, OOP development, you can have imperative programming, all in the same program, okay? And that's not always a great thing, okay? Because it's hard to figure out what parts of the code are doing what. And the code that you might write in your labs or in something maybe hundreds of lines of long, and maybe pushing 1,000 at some point. But real world programs and APIs run to hundreds of thousands of lines and millions of lines of code, and that's when it starts to become a problem. Okay, so we like to have. There are lots of reasons for having OOP, and I think sometimes when you start programming with Java, you're focusing on learning to program, and you don't really think about the concepts of programming and the different approaches that you can have for programming. And I suppose the whole idea here is to try and revisit some of those and bring them to your attention because they are core to software design patterns. Okay, absolute core. So what you really should find then over the course of this module is that anything sorry, there's people talking here. I really can't focus if you're going to talk at the same time as me because I can hear everything you're saying. Is that okay? Is it okay? Yeah? Yeah, thanks. I don't mind if you want to talk, maybe leave or come back in, that's fine. What you'll find is that the OOP principles that you have from this module with C# work with Java, they work with C++, they work with object-oriented Python, and lots of the other OOP languages as well. So you can bring these across. And later, when we get to the software design patterns, I'll be recommending a textbook. It's an online book. It's about $10, but there's an accompanying website. So everything that's in the book is also in the website. So that's why I recognize you don't have to buy it. But the beauty of this book is that it shows you how to implement all of the patterns in all of the different languages. Okay, so the same pattern translates. It's really important, and I know many of you are doing interviews at the moment, and some of you have mailed me today to tell me you've got interviews scheduled at a moment's notice and can't come to labs. Well, I understand that that's an issue, and thank you for contacting me about this, but try to get to a different lab if you can, okay? Just send me the time and then we can move you back and forth between the labs a little bit. I'll come back to labs a little bit later. But you will find that all of this stuff can be reused. And if you ask something about a pattern, for example, in an interview, and you know about this with Java, and they ask you about C++, you haven't got there yet, you can say, well, look, I'm doing it in one language where I understand the OOP principles, and once I understand them in this language, it's fairly straightforward for me to apply them elsewhere. So, look at ways in which you can actually answer the question based on what you know and how it generalizes. Okay, don't just say I don't know. Okay, think about this. Yeah, you will have some skills that you don't realize you have. I guess today we'll try to revisit some of those. So the first thing we need to do is just to look at the language. And it's really important that I said this last time, it's really important that you grasp the language of development. And because when you look at the patterns and they describe the patterns to you, they're going to use this language. And you have to be absolutely clear that you understand the language. Okay? A lot of the time people refer to thing or program or code and don't actually refer to a class as a class and don't know the difference, for example, between a class and an object. So what is the difference between a class and an object? Does anybody want to tell me? No? Don't want to tell me. Okay, somebody wants to tell me, yes. They're derived from classes. Okay, the class is a template, but it's close. Yeah, okay. They're often, have you heard of the word instantiation? No? Okay, so objects are instantiations of classes. In other words, a class is a general template, and there's an instance of that class. Okay, so it's like having a plan for a house, building plans. You've seen plans for that new building out there. The actual the actual entity that's produced using that plan as a template is an instance of that class. And so therefore it becomes an instantiation. And that's the object. Okay? Do you often hear that classes are there to make objects? Well, we like to and prefer the word instant to create an instance. And that's the instantiation. That's where that comes from. So object-oriented programming, OOP, is a programming paradigm. Okay? Lots of people use the word and they don't know what the word means as well. So maybe if you don't get it, look it up. It's an approach, almost like a philosophy discipline. The applications or programs, they're organized around interacting objects, which are derived from classes, or they're instantiations of classes. Classes are templates for objects, and objects are instances of classes. And at the very core, objects have attributes, and that describes the feature of the object. And then they have methods, which provide an interface for interacting with the object. So we try to think about our model of software and our model of applications as a collection or a deployment of objects that interact with each other using methods. And this can bring problems, or it can bring beauty and solutions to what you're trying to do. So if you think a lamp object, for example, that's just an instance of a generalized lamp class that has a state, which is an attribute that can have two individual states called on and off, for example, and the interface could be a toggle, which is a switch that changes the lamp state with every interaction. You might have an on, an off, a toggle, whatever, but just keep pressing the button and it changes the state. Okay, so objects instantiations are able to use their interface methods to change the state or fields or attribute values, and it's like sending an object a message. And we often talk and hear about OOP as a form of message passing. You know, like if you take a modern car, or you take a, you know, if you take a, is there a connection between the steering wheel, for example, and the drive mechanism? You know, when you press the brakes, is there an actual connection? Is there something that connects? Or is it sending a message to a braking system that does the brakes? Or if you steer, does it send a message to a steering system to change the steering? Okay. Could you steer it in some other way? If you think about modern cars, like Tesla cars or something that are self or autonomous driving, then you know the message can come from you as the overrider, or the message can come from the software. Like drones, you know. Most modern warfare, you know, utilize drones. Okay, who's pressing the buttons? You know, so these are about sending messages to various objects. Okay, I often think and often say that, you know, the really interesting, strange thing about computer science is you could be just building the soldiers of the future. Okay, because lots of the way the military is going is all about, you know, software and control. But anyway, that's for another story. Okay, so I really need you to know these words, and the words that are in orange on this board are the ones that you need to be able to be familiar with and be able to use confidently and competently when you are interviewed. It's one page, you know, there are not too many there, but it tells you everything you need to know. So when we're dealing with objects and classes, we have these other terms as well that we need to be absolutely sure about. So we talk about class variables. So when you have a class, what's a class variable? And a class variable belongs to the class. These belong within the class. Okay? And usually there's only one copy of each variable. So, you know, that's really important to know that it sits within the class, so that every object which becomes an instance of that class doesn't keep its own copy of that variable. Next thing, you have instance variables, and instance variables are when you have variables that appear in every single instance of that class, or every single object. And they can exist in addition to the class variables. So for example, if you have an object that changes an instance variable, it only changes the instance variable in itself, its own copy. But even if you have a class variable that's changed by an instance or by an object, then it changes it for everybody else as well. Okay, and that can be tricky. Then you have member variables, and that refers to both the class and the instance variables. And we use the exact same terms when we use the methods, so we have class methods, instance methods as well. So you have methods that sit with the class. There's only one of them. And then you have instance methods, which there's a copy associated with each object. So can you give me an example of a class method from your Java? Because Java works the same way, right? You know how to program in Java, so you should know this, yeah? So tell me a fairly standardized class method. Gets are usually getters and setters. We'll come to those a bit later, but they're usually instance ones. So, yeah. Sorry. Okay, so string is in Java is a class, and it has a method in there, which is there, yeah. But let's say you were to write one yourself. Every single class you write has a class. There's only one copy of that. There's only one copy across the actual board. It may be overloaded, but you know what overloaded means? Yeah? Good, yeah, very good, okay. So like, constructors are like class. There's just usually one that helps create the class, yeah? And you may overload the constructor, okay, in many ways as well. Okay, so, you know, you do know this stuff, but you're probably just not okay with the language you're talking about it. And you're going to have to start doing this and come up to this when you start being interviewed about a coding interview. Yeah. So object instantiation, good, by the way, good, thank you. Object instantiation usually involves calling this special method called a constructor. It was on the board already, okay? Don't be afraid to say these things and read ahead, you know. And they can contain parameters that facilitate the initialization or customization of the individual objects using the parameters. And constructors are really important for us because they allow us to be able to control the class and how we use that class. So later on, and soon we'll see a kind of class called a singleton. And it's like, you know, well, I'm a bit older than you, so we always have different phrases for this. We refer to it as a Highlander class because there could be only one, and that's reference to an old movie, right? But you might only want one constructor, and you might only want one instance, and you can't actually create an object. Okay, so how would you have a class and then disallow client software or client applications from actually making objects with that class? Any ideas how we might do that? You know Java, right? You've done, yeah, okay, you can code. So yes? Abstract class have to be instantiated in order to be able to use, yeah, but that's okay. But let's say it's not an abstract. Let's say it's a class, you haven't done anything abstract with it. It needs methods. Abstract classes need methods to it. So you're close, yeah, same, basically, because you're thinking about access, right? So what are the access modifiers that we have? Private? Who said private? Yeah. Make your what private? Not the class, because if it's private, you can't actually access it at all, yeah. Not necessarily methods. Okay, let's just man at the back here. Okay, yeah, but so what do you make private then to stop you actually being able to make a class? Make an object from a class? The constructor. Okay, yeah, very good, Precious. Okay, so it's the constructor, okay? You can actually, and we do these things called singletons where we can actually make private constructors, which means it can't actually be called. You might say, well, why would I want to do this? Is we want to control the class. You want to control who can access and do with the class. You might actually provide access to an object. So you can have an object inside the class. So a class can create an instance of itself inside itself because it has access. And therefore, we can actually give access to that one and only single object from within the class, but people can't actually create instances of that class themselves. You know, this is actually quite cool, right? I mean, you might not think it, but actually it's quite a cool thing to be able to do, okay? And it's at the core of much of the patterns and things that we will look at. You understand this, you can understand lots of the others. Okay, so here are a couple of the other concepts that you need to actually be familiar with. They are both, and I know you know some of this already because somebody mentioned abstraction already, which is one of them, and the first is encapsulation. And so one of the principles of OOP is that you have encapsulation, and that basically says that, you know, your class is essentially a wrapper around all the stuff you want to be able to do, and then that Objects outside of that don't have access. You can protect them. They're only able to call the object or a class interface, and that might be a list of publicly available methods. So the approach to data hiding is it gives you enhanced code security, and that's right, means that you can't unintentionally corrupt the data. That's why we have it. Okay. And abstraction then, objects means they only reveal the internal representations or mechanisms to other objects when necessary. Okay, so you know this, I won't go through this one too much. Inheritance and polymorphism are the two other final pieces of OOP that's really good, okay? So inheritance relates to class hierarchies. So you might have subclasses between objects. They allow developers to reuse or share code or logic while maintaining this unique hierarchy. And the key principle of OOP requires thorough data modeling, reduces development of time and errors, and classes inherit class members if permitted to do so. That's all about accessibility. And that's useful. So instead of writing new code from scratch, we inherit functionality from other classes that are already written. Okay? And that's key, right? That's really key. It saves coding time. When something is done, you don't break it. You know, you don't you keep it there and make it work. You know. Polymorphism is really interesting, right? Polymorphism is really one of the most exciting things about OOP. And it tells us that objects can take on more than one form, depending on the usage context. So at runtime, the program will determine which meaning or usage is actually necessary for each specific execution of that object, and it reduces the code duplication. That's the same method set. Okay. Yeah. So polymorphism is really, really nice, you know. I mean, and you know, it happens in real world stuff as well. Okay, I was on a flight one point many years ago, and there was somebody got sick on board, and they said, they came and asked me, because they saw it was Dr. John, you know, and they saw this and said, "Can you help?" And I said, "No, I can't do any of that stuff, right?" You know. But then they said, so they made an announcement, and they said, "Is there a doctor on board?" You know, not the greatest thing to hear, but so a man just across from me stood up and said, "I'm a surgeon, I can help." Okay, that was polymorphism in action. Okay, because essentially he was considering himself to be a surgeon, which was a more specialized form of being a doctor, but he was able to do the general doctor stuff as well. Yeah, so in that context, polymorphism was working. He was able to fulfill the role of being the doctor, even though he was a surgeon. Not all doctors would be able to fulfill the role of being a surgeon, but in principle, the surgeon should be able to fulfill the role of doctors. And that was like the polymorphism. So it's like we do this with objects, so we can go forward sometimes. And we often think in terms of class hierarchies as specializations, more specialized forms. But you should be able to handle all the other forms. Should be. And when we look at software design and we look at the principles, the solid principles of software design, these are key. These kind of things are key. And you'll need to know this. I'll be asking you this in the exam, okay? I always ask this stuff in the exam. Maybe ask for examples. So you need to be able to think about having good examples of each of these for your software, okay? And remembering them. We're going to see all this stuff in C#, okay, as well. So it shouldn't be a problem. So I'm talking about OOP as if I'm some kind of OOP zealot, right? You know, I learned to code in the days when this stuff didn't exist, you know, and I was quite happy and competent coder well before any of this stuff. Wrote hundreds and hundreds and hundreds of thousands of lines of code, controlling telescopes, controlling observation cameras, writing assembly language code for all sorts of stuff, viruses, everything. I wrote all sorts of stuff as a young man, okay? And before OOP was ever considered, okay? You know, you don't have to do it this way, okay? But it's a modern way, and it has been criticized by developers for lots of reasons. And you know, you might say, it could be a question you could be asked, an example, why would you bother with OOP? Like there's, you know, and have an answer. Okay? I require you to do it for this course, so hey, that's unfortunate, really, maybe, but it could be a true answer. But functional programming, that focuses on the evaluation of expressions rather than the execution of commands. Really nice. You'll see lots of functional programming languages that are really, really good. You know, there's structured programming. There are 3 ways. In other words, sequencing, selection, iteration. And they say that's sufficient to express any computable function. And there's imperative programming which focuses on describing how a program operates. There's more, okay? Right, but I'm highlighting these ones. But the developer's largest concern that OOP overemphasizes the data component of software development and doesn't focus enough on the computation or the algorithms. OOP doesn't effectively handle concurrency. Do you know what I mean, concurrency? Where we have two things running at once. Okay. And it may be more complicated to write and take longer to compile. There's a brilliant article here, Why Are So Many Developers Hating on Object-Oriented Programming? It's a 2019 article by David Cassell. It's really worthwhile reading. It's the kind of thing that you should, it's kind of background stuff that you should have, where you're reflecting on what you're doing and reflecting on the kind of coder you are. You know, and the way you're reflecting also on the kind of coder we're trying to make you. You know, you can say, John Keating taught us this stuff, like, you know, it's been the bane of my life, and I'm doing it this way because he made us do it, and now I don't know any other way, and in 10 years' time, you'll be in industry, and you'll think, oh, I'm stuck in this because I did that class, right? You know, and now there are better ways, because we often tend to stick with the way we do stuff. But I really want you to think about who you are as a programmer and how you work. And do this, okay? It's the kind of stuff that one might get you a better job a little bit later. So please think about it. And it's also good for you to think about what you do and who you are and how what you bring and your ideas and your approach to problem solving bring yourself into your programs, because that's the way you do things, you know. I'm quite reductionist. I always look for, like, what are the minimum number of lines of code that I can write to get this job done? Complete mercenary, you know, because to me, getting the job done as efficiently and as quickly as possible is the kind of way I learned, and it's the kind of person I am. Yeah. So it's useful, really useful. So if you want to, if some of these concepts were a little bit rusty, okay, and you know you weren't able to answer some of the questions, or maybe you were able to answer the questions, I'm sure, and you just didn't want to stick your hand up because that's what classes are like, then there's a really good article here on Free Code Camp. Have you used Free Code Camp? It's a brilliant resource. It says How to Explain Object-Oriented Programming Concepts to a 6-Year-Old by Alexander Petkov. Sorry. It's really accurate, it's insightful, and it's not in any way patronizing. Don't be put off by the fact that it says 6-year-old in there, okay? I mean, it's really useful, because sometimes you need to be able to explain something simply and quickly to somebody who doesn't get stuff. And you may be lucky enough to actually be someone who sits in front of a client, yeah? And they ask you questions, you know, and you know, that can make or break a software deal. So sometimes you have to be able to explain to clients who don't know about this stuff what's going on, because they ask, you know, they'll read an article where somebody says OOP is great and say, well, is OOP, you using OOP, you know, or do you have a widget involved? Because I read somewhere that that's a great thing to have, you know, and that's clients and that's customers, and you have to be able to explain it to everybody. That's really nice. It's very, very good. And it's about being able to succinctly and accurately explain OOP in an interview context. Okay, you have to go beyond copy and paste. You know, like I was looking at an example there this morning, because you know you have to remember some stuff. You know, and I always have to try to remember. So here's a really interesting piece of C#, which deals with lambda expressions. We haven't got to this yet. Okay, but it's an interesting line of code. And I was looking at this. Gosh, you know, there's a class, you know, and here's a delegate into cube, and we have this lambda expression here. And you think, so, well, how do I explain what's going on here? You know, how do I explain? You know, you should know this stuff at some point. You know, but like you could just copy and paste and run it, and it'll tell you that the answer is 1,000. Well, what's going on and how's it happening? Okay, an explanation of what's happening. And sometimes when you hit an interview, you'll be asked to explain what's happening here, or what will the output of this piece of code be? You have to work through it, you know. It's not being able to copy and paste it and run it and say, oh yeah, that's the answer. You have to do it in your head. Yeah. This is quite a complex piece of code, actually. You know, it's an interesting piece of code, quite complex piece of code, and we see a little bit more of that later, okay? But please go beyond copy and paste. It's like sometimes people says, you know, I have the notes, so I'm grand for the exam. Or I have the example programs, I'm good for the exam. But actually, you have to actually do something with them and understand them. Having the stuff is not enough. It's like buying the books is not enough. You have to read the books. And then maybe reflect on the reading. then do something, okay? This is what gets you. This is what gets you good marks. And you know, you're very lucky in the labs that you have a whole bunch of people in the labs supervising the labs who are like 95 to 100% in the exams. There are people who got 100% CA and maybe just made one small mistake in an exam or something like that, if they just got lower than that, okay? You have really good people, they understand this stuff, you know? So use them, okay? Use them, stretch them. Please, do, please. It's really important for them. Okay, so it's a good thing to do. Okay, so here's the most important start. Access modifiers, as our friend at the back here mentioned earlier, is really, really important. The ones that we have in C# are very similar to the ones that you encounter in Java. We have public, protected, private, and internal. And then there are actually combination access modifiers called protected internal and private protected. And then, you know, you should know this stuff already. I'll leave the sign, but we can see examples of this so that we can speed up a little bit here of what's going on. But anything that's marked public or isn't, or you know, is can be accessed from anywhere. Protected members are accessed only within the class itself and are accessed by inherent parent classes. And private members are limited to the containing type, only within the class or its interface. And internal members can be accessed within the same assembly. That's a .exe or a DLL, and I posted a video recently about how to work with DLLs. Okay, so you can see that. And we can worry about the others a little bit later. So this is the table that you need to be familiar with, you know, and it tells you who can access what and where they can come from. Okay, and I took this one from Zcode. It's a really nice one, and certainly worth having just to hand. It's useful, you know, because sometimes the program doesn't work. You know what happened? You get some errors, and you know, always go back to the table when you start get this kind of problem. You know, and understand. Like I'm a great believer. If you understand this stuff first and foremost, it helps you get a solution to an error quickly, knowing where to find stuff. So that's why it's here. Okay, so we're going to have a look at some C# programs now and some encapsulation. And this is a very standard kind of hello world OOP program that you would see, and you've seen and you've done it in Java. And it's about encapsulation because it shows you how you have class members, instance variables, methods, and it shows you how to use the access modifiers like public and private. And it's called myaccess.cs, and you can find it in the demo zip file online. One of the things that's interesting here is that, okay, if we look at the top program here, we have a class called person. So it's a very straightforward class. We're going to use it to make person objects. And then we have a public string name and a private int age. Okay, so that shows us how we can actually do this. You know, we can make an internal member, data member, in this case, private or public. You know, I see I've made that name public up there. Really bad idea. Fields, internal data in a program, you never make those public. Okay, you always have them private, and you set up accessor methods, getters and setters, in order to be able to access those data. So there are a few ways to do this. Okay, if you look at the bottom one here, which is not commented through, you'll see we know the age is in there. We might have a get age and set age. Okay, and we could have something similar for get name and set name, except in this particular program, we wouldn't do that because we've made it variable already. We've made it public, so we could actually just directly the object name dot name. We can manipulate it that way. It's a bad idea. But you'll notice here in the middle, in the green section, because it's commented, we would change this in a way. So we would have a private string for name, which is a good way to do it, to make our fields private. And then we would have a property called capital name. And then we can set a getter and a setter method using these. So we say a getter method will return name, and a setter method will allow us to be able to assign the value that's passed. And this get and set are kind of a shorthand notation for setting up methods, accessor methods on this property name. So we can say something like name is assigned the value of Joe Bloggs, or we might use name in a print statement. So the context in which that public property name is used determines whether we're calling the get method or the setter method. See that? It's the context in which it's used determines which one is called, whether we're assigning a value to it or whether we're using it in an evaluative context. Let's have a peek. So here's the program. It's in this directory. I'll just move some of these across so we can see a little bit better. Let's okay, so here's the program. I've made it slightly actually you'll see this program here is slightly different to the one that's on the screen because I've actually done this as well using lambda expressions. It's another way to do this. So you'll see this you'll see this in demos all the time. Okay, but let's start working with the one we have. So we get the age and we set the age, and we've got this class called person here. It's no access modifiers on the class itself, so we can access it and use it. And then we have a program here that creates a new person and assigns the value of name Joe Blogs. Okay, and commented out this piece here because we can run it again by uncommenting different parts of the program and seeing how the different ways you can do the same thing. Okay, and then we can say that Joe Blogs is what 40 years old because I'm using this method here. And you know you all know how to do this, but let's do it anyway. Okay. So this is fine, and so we get the result that we would have expected. So let's look at the other section now. Okay. So now let's get rid of this terminal and make some small changes here. So we want to comment. Oh gosh, we don't want to do that. We want to comment this section out here, and we want to, and this is what I mean by don't just copy and paste and run. You want to start making some changes to these things here. Let's uncomment this. Okay, so now we have this problem here, okay? The problem tells us because it's already been defined with a different access up here. So we might want to get rid of this, comment this here. So now we can run. And we're working with the names here. Okay, and now let's play with this. Remove this. And let's do this. Do this. And we don't have a set age, so we need to get rid of this one. And it looks okay. Okay. He says, hopefully. Okay. Did I do? Okay. Where's age? We're just dealing with names, so we don't have any age here. So let's get rid of this one here. Let's copy this. Suppose I could do that. Oh, well, let's just do this. Person doesn't contain a definition for get age. Okay, so that's fine. Let's go back and do this again. It's a problem with commenting and uncommenting. Okay, so here am I. Oh yeah, sure, I'm doing this. That's okay. I tend not to stress too much when I get some errors, you know, and so forth. So here we go. That's okay. And this is just a warning because the person that age is never used, and we didn't use it, and that's fine. You know, we can update our code, and we get the response. So I guess what's happening is in our code here is that we're using. Oh, let's go back to this window here. You'll see that in this particular piece of code here we're accessing the property name, and here we're assigning a value to the property name. And so it knows at runtime whether I'm using this version or this version. Okay. And it's a lot neater than having to use all of these gets and sets. So this is the preferred method, and this is the even more preferred method. Okay? Yeah. Yes? Yeah. There's lots of versions, okay, of how to do this. So we this is a more preferred way once you understand some lambda calculus, and then when you understand this, you can do an even more shortcut. Okay, my as a friend says here, you know, there are lots and lots of shortcuts to make your programs a lot more efficient. My thoughts on this are, I love the most efficient way, but not everybody can read it and understand the way. Okay, so once you understand one way, then you replace it with a more efficient way, and then you understand that way, and then you replace it with a much more efficient way again, rather than just going straight for the most efficient way and shorthand notation you can, because then when something goes wrong, you might not know how to fix it. Okay. And C# is full of lots of tricks, and I mentioned earlier, I love shorthand notations wherever possible, and it's useful. And again, if we go back to the example here, where we looked at this example here, which essentially used a lambda expression as well. And actually, let me go back to that. Let me go back to this. So what's happening here, not here, in this one here, what's happening here is that this is a lambda expression, okay? And what you have here is you have an input on this side of an expression, and this is the expression itself, and this input gets taken into the expression and it's returned. Okay, so the result of that expression is returned, and that's what's going on. And essentially, this is what's going on here as well. So we have this lambda expression here, which takes a as input and multiplies it 3 times, cubes it, and then assigns that expression or function, if you like, to this get cube. Okay, which we have a delegate later that says we'll tell you how this actually works later. Okay, we'll just tell you that it's coming, but we're not going to tell you how it works yet. But later in your program, you'll define and decide on it, and then we can execute it. So you'll see lots of these kind of things, lots of shorthand notations, but start with a version that you know, and then work forward and work forward and work forward. Any questions? Yes. Okay, but just to review, these are normal getter and setter methods. These are properties. Okay, these are fields. These are accessor methods, or accessors to the properties. Okay, and sometimes we can create these, or sometimes we can also create these accessors, I suppose, using lambda expressions. Okay, that's the language that you need to be sure about. Okay. Okay. Notes. Somebody asked me at one point about making tables. Okay, so I have written I've written a little piece of code here for you on OOP tables. So how do I make tables? So I was showing how to make a table because they needed it for an assignment or something. And here's a way of randomly generating a table full of data. It's not necessarily the most efficient way, but it shows you how to do it using OOP based on today. Okay, and it might be useful once you have a table and you can use it to generate some programs. So Mark will talk about this in the tutorial this afternoon. Okay, and show you how you can generate code as a class. Okay, so I was saying that a solution to the current assignment would be to have an internal representation of a table. Okay, have one internal representation of what a table looks like. Okay. Then when you have that internal representation, you can use it to generate an output. You can have a output as HTML, output as Markdown, output as well. And that's an easy way to do, okay? So everybody should be working on getting that part done first. So you have an internal representation of any table, then you write the methods or you write the functions that generate the formatted output from whatever is in that table. So it's a double loop. You iterate over it, and you write out the top and tail for the HTML table or JSON or whatever. So it's very straightforward. There's loads of marks that can be gained in the assignment just by having an internal representation for a table, having a method that then generates all the different formats. And you just populate the table internally with whatever data you want. That's a great way to get marks. The hard bit is to try to convert from one to another. So the trick, of course, is not to try to convert from one format to another format, because you'd have all sorts of messing to do with that. What you do is you always take the input and convert it so it goes and fits into your internal tabular representation, and then you can generate any type you like from there. You see that? That's the strategy. You know, you don't want to write converters from one type to another type. You always convert it to an internal representation that you know, and then you use that to generate whatever is required afterwards. So the easy part is generating all the tables of different types once you have a table data array. The hard part is converting and parsing some of the input so that it actually gets into the table format that you can then use to generate whatever type you like afterwards. You see that? That's how you quickly get this thing done. A couple of hours, you know. This is how you quickly do it. And use Newtonsoft.json or Newtonsoft library to parse JSON. You know, you can use regular expressions to parse some stuff, but you can actually parse a table with regular expressions. There's loads of ways you can do these things. Markdown, easy to parse with regular expressions as well. So it's not hard, but it is the hardest part. This is the dead easy part. And so what I did then is I say, well, hey, we're interested in OOP, so here's how you make an OOP method, and then you can write and add another method that just takes the information from the table and writes it out as HTML or text, or whatever. Okay, so Mark will discuss this in the tutorial, and I've asked him to extend the program that I've developed for you so that it also maybe generates a HTML table. Once you can do one of them, you can do all the rest of them. Okay? Please, I'm always happy to get questions from people, you know, mail me and say, you know, could you maybe give us a bit of a demo on how to do this or something like this? I'm always happy to do that kind of stuff. Ask me. There are days of the week when it's a good idea to ask me, right? You know, don't ask me like at 6 o'clock in the morning on, you know, a Tuesday. You know, I'm probably playing games at that time. Okay, I'm busy, right? I have dailies to complete. You know, so like, you know, this is not a good time, right? But if you ask me at Monday morning, then I'll probably have some time on Monday that I can put something together and give it in the class, okay? Yeah? So get your timing right with your questions and then ask me, and then I'll do my best to be able to get you something there, okay? Okay, let's get back to the rest of these slides. Okay, so inheritance is another concept that we've done, and I've given an example here where we have a base class and a derived class. And I've used these terms because they're the terms you need to know how to use, okay? I've called one derived and I've called one base, okay? And so we have a parent class or a base class, and we have a child class or a subclass. I don't like subclass because it makes it look like something like less important about it, okay? It's actually, it's a highly specialized class. Okay, so it's a derived class in some way. And so we have this access modifiers, and depending on whether they're protected, private, or public, allows you can or cannot access this. So again, we have this little program. It's been distributed for you in the zip file, and you'll be able to look at that. Notice the use of colon here. Class derived from a base. So in Java, you use extends or something, yeah? Yeah, so and implements an interface or something like this. Yeah. So you'd have that. And remember, Java is a single inheritance, so it doesn't allow you to be able to inherit from two classes. C# is much the same, but a lot of the time we can set up interfaces and you can inherit from multiple interfaces and classes. and it gives the appearance of multiple inheritance. C++ does allow multiple inheritance. Okay, you have to set it up in a way. So we don't play with C++ in this particular class, but you'll see it in others. But so the stuff and the approach that you would have to inheritance and class generation and class hierarchies in Java will also work in your C# for you. So maybe play with this demo here. And I'm just working with instance variables in here. It'll also work for methods. Here's an example of polymorphism here, and I took my example, I think, from that article I mentioned earlier, where we create animals that have that make a sound, and then we have a cat here that extends the base class animal, and we override. You use an overriding method here, and we change the sound to say meow. We have another of a dog and says woof and so forth. And here the base class animal sound method is as the animal just makes a sound, and then we can specify it in a way. Now, this is only half the story, because if we look at the example code that I give you, I'm looking at how you might actually not just this code here. It's just a small example here, but polymorphism always relies on overriding methods. And if we look at our window here, let me just be a good idea to put my glasses on. So if we look at the examples that I have for polymorphism, my poly here, you'll see that I've set up a whole bunch of contexts where we actually have an animal, which is my animal, my cat, animal, my dog. So it's different from actually where we're creating a new cat and a new dog. But actually, what's the difference between the base class that's used, the class that's used to actually create the instance variable here, as opposed to how it works with instantiation? So by playing with this, you can decide, well, what actually is said here, okay? And we can do all sorts of fun things by playing with these and actually figure out what the sound that will be made by working with this. Worthwhile having a look at this example and playing with it. We also need to look at abstraction, and somebody mentioned about abstract classes earlier, and it's great to hear that you remember all this stuff. And when we have an abstract class, really what that does is it tells us that we're hiding information. So we're saying that a particular class must implement a specific kind of interface, but we're not saying how it works. It's up to the derived class to be able to make that implementation or that reality. Okay, and it's a restriction. Okay, and it's a really good way to do sorts of restrictions. And that, remember, abstract classes can have both abstracts and regular methods as well. Okay, they're not all just all have to be abstract. And that, in conjunction with polymorphism, the inheritance hierarchies, allows us to be able to do all sorts of fun stuff with C#, just in the same way as we can with Java. Okay, we learned a good bit about OOP today. We saw some of it working in C#, and I hope to see you using it in your examples. Thanks for coming. Appreciate that.